Under the early November sky, the footage begins with a slow zoom into the Arizona desert. The narrator's voice is calm, deliberate, the tone of a man trying to sound composed while standing before something that quietly rearranges what we think we know. A new image taken from the LOL Observatory near Flagstaff appears on screen. Researcher Kang Zhang's 152mm telescope glints under the moonlight as the camera lingers on a digital screen, showing the faint blue trace of a comet. The voice explains that this was recorded on November 2nd, 2025. Nothing about the frame looks extraordinary until the narrator adds, "This is 3IATLAS. And this is the moment the story stopped belonging to astronomy alone." The screen fades to black, replaced by the logo of NASA's Mars Reconnaissance Orbiter. Then the words appear, dated October 3rd, 2025. Image locked, access restricted. The narrator continues, "That date matters because that was when Atlas crossed near Mars's orbit, 27 million kilometers from the planet, and for the first time, a human-made eye looked directly at it." The tempo of the music tightens. We see mock-ups of encrypted files, scientists sending requests, and automated replies stamped under review. The narrator's tone sharpens. Those images, the highest quality data humanity ever had of Atlas, vanished into silence, locked, redacted, waiting somewhere behind layers of authorization. A few seconds of stillness. Then a headline flashes, "NASA responds to Kim Kardashian." The narrator almost sighs, incredulous. When a celebrity asked on social media if Atlas was dangerous, NASA replied in 20 minutes, "No aliens, no threat." Yet when congressional science committees and astronomers demanded access to the raw Mars orbiter images, there was no reply at all. The screen fills with tweets, statements, silence. That contrast isn't just embarrassing, the voice continues, it's the fracture line of public trust. When communication becomes a performance instead of an exchange, science turns into theater. A faint background hum grows as the footage transitions to a table of spectral readings. Nickel peaks shimmer on a graph. And then, the narrator says, came the spectrum that broke the silence. An image of Elon Musk speaking at a conference appears briefly. He mentioned that some cosmic bodies can be rich in nickel and iron. True enough. But that comment left out what the independent observatories noticed. Atlas carried far more nickel than iron, ratios unseen in any natural asteroid. The narrator's tone lowers, measured, skeptical. To refine nickel away from iron requires industrial separation, electrolysis, chemical baths, high-temperature processing. In nature, iron dominates, always, unless the screen cuts to a 3D rendering of a rotating metallic sphere, half glowing, half shadowed. Unless someone engineered it. A pause. The camera pans slowly across faces of experts, statements on screens. A quote from astrophysicist Avi Loeb fades in, "Anomalies deserve data, not dismissal." The narrator continues, "But data was precisely what we didn't have. The Mars images still sealed, the nickel ratio disputed, and in the middle of it, Atlas kept moving. Images of its trajectory appear, a looping animation tracing its path past Mars, skimming the inner system. The voiceover explains retrograde orbit, perfectly aligned with the ecliptic plane. Only 3% of random trajectories could achieve that by chance. 3%. And yet Atlas moves opposite every planet's direction while remaining almost flat to the same plane that hosts them. Either it's the universe's strangest coincidence or precision." The narrator pauses, allowing the weight of the thought to settle. Retrograde motion alone might be chance. But combine it with alignment, and you start seeing intent. It's as if something charted a course, not merely passing through, but gliding within the map of our solar system. A sound cue swells like a distant engine. The voice hardens. Then came the jet. Footage of telescopic images from July and August flashes. Instead of a tail pushed away from the sun, the narrator explains, Atlas grew a jet pointing toward it, against radiation pressure, against physics. The image glows with simulation arrows, particles streaming inward. To move vaporized material toward a star defies every law we teach about comets. It's like watching smoke flow back into the fire. There is silence again. Then a line appears on screen. Unknown propulsion mechanism cannot be ruled out. The narrator reads it quietly. Not my words. Those belong to a European Space Agency report marked internal draft, leaked last month. The music lowers into a bass thrum. This was no longer about astronomy. It became a question of control, of access, of who gets to ask, and who decides what truth looks like before it reaches the public. The camera pans over printed emails, congressional memos, university requests. The narrator continues, formal petitions went unanswered. Researchers reported that sections of the MRO database returned blank values, as if the entries had been overwritten. A beat, then his tone turns analytical. Let's look at what we do know. Atlas weighs roughly 1,000,000 times more than Oumuamua and moves faster. That combination alone breaks the gravitational logic we expect. Heavier bodies tend to move slower if they come from similar distances. Yet this one accelerates, massive, deliberate, steady. On screen, an animation compares Atlas to a freight train overtaking race cars. The narrator adds, to maintain that speed, something had to give it energy. And if that energy isn't from a natural outgassing, then from where? The question hangs unanswered as visuals of scientists debating fill the frame. The narrator shifts tone, now almost reflective. This is how science breathes, through skepticism, through debate, through data. But when data is withheld, what replaces it is rumor. And rumor, when fed by silence, mutates into fear. The next scene shows NASA's Twitter feed side by side with scrolling academic petitions. The narrator says, a 20-character tweet can calm millions, but a sealed file can unsettle a generation of scientists. Public relations outpacing peer review is the modern symptom of an information age running faster than its own conscience. A faint chime signals transition. Then, new readings arrived. From Chile, from Hawaii, from amateur observatories, stitching together frames across continents. They confirmed a reflection pattern never before seen, a polarization of light so negative it broke every model. The narrator describes it slowly, like unveiling a crime scene. Light bouncing off ATLAS didn't behave like dust or ice, it behaved like metal. Smooth, oriented, manufactured. When electromagnetic waves line up that cleanly, it usually means one thing: structured surfaces. A pause. Structured, not chaotic. The score builds with low violins. And that, the narrator says, was when the idea stopped being fringe. Industrial metallurgy in motion, retrograde alignment, anti-solar propulsion. You can dismiss one anomaly, maybe two, but 9? Images flash rapidly. Graphs, blueprints, photos of glowing comet tails, snippets of news commentary. The voice tightens. We began with curiosity. Then we stumbled into contradiction, and now we face the possibility that something is deliberately not what it seems. He exhales softly, almost as if steadying himself. The Mars Reconnaissance Orbiter holds the clearest images we will ever get before Atlas leaves our neighborhood. Each hour of delay is an hour of uncertainty amplified. Static flickers. A distorted image of a metallic crescent forms, unclear, almost suggestive of an artificial shape. If this is what's hidden in the locked files, the narrator murmurs, then the question isn't what Atlas is, but why we weren't meant to see it. The music cuts abruptly. The screen fades to black. Only one line remains, written in pale gray text. Part 2. The data we were not supposed to have. The screen opens on a dark room lit only by the bluish glow of computer monitors. Lines of code scroll by as the narrator's voice returns. Lower now, more personal, like someone who has seen too much to remain neutral. They said the files didn't exist, the voice begins, but they did. For 47 minutes on October 5th, a test mirror of the Mars Reconnaissance Database was accessible to public institutions. One team from Geneva managed to extract 6 image headers before the servers went offline. The visual shifts to simulated data logs, timestamps, image IDs, orbit coordinates. Those headers confirmed what everyone suspected. The orbiter had recorded high-resolution optical and infrared footage of Atlas between October 2nd and 3rd. The data was then flagged with internal code Tier 1 Restricted, a classification normally reserved for planetary defense threats or artifacts of unknown origin. The camera pans across a screen where an astronomer's hand scrolls through blurred thumbnails. None of the 6 images show a typical comet coma. Instead, they show a compact reflective structure with symmetrical flares. Geometry, not gas. The narrator's tone tightens. It's possible those flares were optical ghosts, distortions from the camera sensors, but it's also possible they weren't. Footage transitions to an interview clip. An older scientist, face shadowed, voice modulated. If that reflection pattern is real, he says, then Atlas has facets, flat planes. That's not dust. That's design. The narrator cuts in. He spoke anonymously. He no longer works with NASA. A swell of electronic static grows as the screen displays a headline from November 6th. Data request denied. Mars Imaging Division. The narrator continues. By then, independent observatories around the world had coordinated what they called the Atlas window, 6 weeks of continuous observation between late November and early January, culminating on its December 19th approach. An animation of the Earth's orbit appears, dotted with icons marking telescopes from Arizona to Chile, from Hawaii to the Canary Islands. For once, competition paused. Everyone wanted the truth. As the map fades, a chart overlays spectral data with audio cues resembling mechanical pulses. That's the brightness curve recorded on December 1st, the narrator explains. Instead of fading as expected, Atlas brightened by 37% over 3 hours, then dimmed in perfect logarithmic decay, identical to artificial light modulation. The sound fades, replaced by silence. No natural comet pulses with such precision. None, he says. Brightness changes follow sublimation rates, chaotic and uneven. Not like this. A whisper of wind, the image of a frozen desert sky. At 0317 UTC, radio observatories in Australia picked up a narrowband emission overlapping with the object's coordinates. Frequency 1420.405 MHz. The hydrogen line, the same range used by SETI for decades to scan for deliberate signals. The emission lasted 71 seconds, a moment of silence. The last time a signal like that was recorded was August 15th, 1977, the WOW signal. The narrator lets the words linger, then adds, Atlas originated from a region within 9 degrees of that same coordinate. We see the numbers on screen, 9 degrees plotted in luminous red. Coincidence, he says softly, or convergence? A low percussion begins. The footage now cuts between experts arguing on news panels, footage of public protests outside NASA headquarters, and a cascade of social media posts tagged #UnlockAtlas. The narrator's tone becomes colder, more controlled. For the first time in decades, the science community fractured. Some demanded transparency, others warned against hysteria. But in the silence between those positions grew something worse. A vacuum where speculation thrived. He pauses. And into that vacuum, someone leaked the 7th image. The image fills the screen. Grainy, distorted, but unmistakable. A metallic curvature reflecting sunlight in a way that suggests a hollow frame. It reached a private astronomy forum on December 8th, then spread to encrypted networks within hours. NASA never confirmed or denied its authenticity. They simply reclassified the entire Mars archive and restricted keyword searches. The narrator sighs, quiet but sharp. When an institution erases vocabulary, it's no longer about data, it's about control. The music grows somber, a single cello tracing long, aching notes. Meanwhile, Atlas kept moving. Observers at Mauna Kea detected a faint trail not of ice or dust, but of ionized nickel particles, charged metal drifting like vapor from molten steel. That's not sublimation, that's discharge. An animated rendering shows bright streaks leaving the object's surface. If that's true, the implication is staggering. Metallic ejection would require internal energy, heat, power, perhaps even propulsion. He continues, voice steady but heavy. To accelerate by non-gravitational means without losing mass at a detectable rate is, simply put, impossible, unless what we're watching isn't a comet at all. The scene shifts again to a quiet office late at night. A scientist stares at his laptop, eyes hollow from lack of sleep. The narrator describes him, Dr. Tadeusz Marek, Warsaw Observatory. He was among the first to model Atlas's acceleration curve. His conclusion, the observed vector matched the signature of controlled thrust, consistent with a low-level ion engine. His paper was rejected within an hour of submission. We see fragments of the rejection email, words blurred except for one sentence, unsubstantiated technological inference. The narrator repeats it slowly. Unsubstantiated technological inference. Yet they never disprove the data, only the implication. A clock ticks. The tone lowers into resignation. And so the narrative split. NASA called it a comet with unusual properties. Independent teams called it a visitor. The screen now fills with slow footage of Atlas itself, a luminous blue tear gliding through blackness. The narrator's voice becomes softer, almost reverent. December 12th, the last week before closest approach. Telescopes worldwide turned toward it. No debris cloud, no coma. Just a clean, brilliant point moving faster than anything its size should. He inhales audibly. If it was natural, it was the strangest natural object we've ever seen. If it wasn't, a soft static cuts him off. The screen displays text fragments of a congressional hearing transcript. Data release. Delayed pending national review. Potential defense sensitivity. Unclassified material reclassified retroactively. The narrator almost laughs, bitter and tired. Science buried under bureaucracy. Truth postponed by paperwork. A beat. Yet even now, something remarkable was happening. Amateur astronomers, digital archivists, and open-source investigators began cross-referencing timestamps, orbital mechanics, and scattered leaks. Piece by piece, they built a mosaic of what the agencies wouldn't show. The screen becomes a digital map, dots connecting across continents. They called themselves the Atlas Network, students, scientists, coders, ordinary citizens. For the first time, knowledge wasn't centralized, it was shared. The music swells again, this time not ominous, but determined. Because in the absence of authority, collaboration becomes rebellion. The narrator pauses one last time before the screen fades. December 19th, 2025. Closest approach. The night Earth looked up, and something looked back. The sound of a low-frequency hum builds, almost beyond hearing, until it merges with silence. Then the words appear. Part 3. The moment of transmission. The image begins in total darkness. Then slowly, a sound, low, rhythmic, mechanical, fills the silence like a pulse coming from somewhere deep beneath the static. The narrator's voice returns, steady and low. December 19th, 2025. At precisely 4:42 UTC, Atlas reached its closest point to Earth, 38 million kilometers. Every radio dish on the planet turned to listen. We see flashes of observatories across continents, Hawaii, Chile, Japan, South Africa, all under the same cold night. Technicians huddle around screens, waiting for a whisper in the noise. And then, the narrator says, the signal came. A soft burst of sound breaks through, a modulation at the hydrogen line, faint but structured. It lasted 23 seconds, a rising tone, perfectly harmonic, followed by silence. Oscilloscope waves appear on screen, then freeze. The narrator continues, it wasn't random. The intervals match the Fibonacci sequence, nature's pattern, but too precise to be coincidence. The video cuts to snippets of reaction, scientists shouting, radio operators calling commands, hands trembling over keyboards. Within minutes, the data flooded servers from Canberra to JPL, and then just as quickly, the feed stopped. Systems crashed simultaneously worldwide. The voice sharpens, urgent. Later, cybersecurity reports revealed that each observatory's data array received an external handshake request from a domain registered inside NASA's Deep Space Network. No one authorized it. The visuals flicker through code lines, warning banners, system logs. By dawn, all original signal data had been quarantined under National Security Directive 51A. Every public archive replaced with white noise files. The narrator breathes out slowly, but fragments remained. Before the blackout, a group from Kyoto Observatory managed to save part of the waveform, compressed, encrypted, but intact. A spectrogram unfolds across the screen, forming a shape that looks like a helix. When decoded, the waveform revealed something no one expected. A pattern identical to the metallic emission spectrum of nickel. He lets that sink in. The signal mirrored the composition of ATLAS itself, as if it was echoing its own material, announcing what it was made of. The scene fades to a quiet coffee shop at night. A woman speaks softly, her name captioned as Dr. Lin Cho, astrophysicist. It was like it wanted us to know. The frequencies weren't random, they were self-descriptive, like a calling card. The narrator resumes, voice weighted with disbelief. And then came the light. Drone footage from Australia shows a streak crossing the dawn sky, bright, silent, deliberate. For exactly 6 minutes, Atlas increased brightness to magnitude -5, brighter than Venus, then faded, leaving no tail, no debris, nothing. The next shot, people standing in streets, filming with phones, unaware they're witnessing the end of something historic. By the next day, it was gone. Tracking telescopes couldn't find it. No residual trail, no radiation echo. A TLAS simply left. A long silence follows. The narrator's tone softens, reflective. In science, disappearance is as important as discovery. But this was erasure. He pauses. Weeks later, NASA issued a formal statement. It described the event as a transient reflection caused by surface crystallization. A natural explanation, elegant on paper, but inconsistent with every recorded measurement. Clips of journalists questioning officials flash by. Every answer deflects. The narrator speaks with restrained frustration. Questions about the hydrogen signal were dismissed as data anomalies. The shutdown of observatories called routine maintenance. And yet, internal emails leaked from Jet Propulsion Laboratory used a different word, containment. We see the email header, blurred but unmistakable. Containment, as if knowledge itself was hazardous. The camera pans slowly through empty observatory halls, silent corridors, unused equipment. The narrator's tone turns almost mournful. For months, the story faded. Public attention moved on. But inside the Atlas network, the group of independent researchers who had been watching since the beginning, the investigation never stopped. A soft click, the sound of an old hard drive spinning up. On February 14th, 2026, they decrypted the final fragment from Kyoto. It wasn't just noise, it was a modulation encoded with binary symmetry. When plotted visually, it formed 9 repeating nodes around a central axis, a perfect 9-fold symmetry, impossible for random radio interference. The image materializes on screen, 9 points circling a core, faint and luminous. The narrator's voice lowers. 9. The same number as the anomalies that defined Atlas itself. The soundscape deepens, layers of electronic hum weaving beneath his words. Retrograde orbit, anti-solar jet, mass velocity paradox, precision encounters, metallurgical signatures, low water ratio, optical polarization, wow, signal convergence, and now signal symmetry. He lets the list hang in the air, each one improbable, alone. Together, they form a pattern that points to purpose. A slow montage follows. Scientists debating, newscasts replaying, public doubt and fascination intertwined. They called it the Atlas hypothesis, that somewhere out there, an artifact, or a fragment of one, was launched eons ago, not to visit us, but to be found. The narrator's tone steadies, no longer accusatory but solemn. Whether it was a relic of intelligence or a natural accident of physics doesn't change what it revealed. That the line between the artificial and the cosmic is thinner than we ever imagined. The next image shows a desert dawn over the Arizona Observatory where it began. Kangzang, silhouetted against the telescope dome, stares at the horizon. He was the first to capture Atlas, the narrator says, and the last to see its fading trace. Before sunrise, he pointed his lens at the empty quadrant where it once glowed. What he recorded wasn't light, but absence, a blankness so precise it measured darker than the surrounding space. Soft music begins, fragile and distant. Darkness isn't the opposite of discovery, the narrator says. It's the shape truth takes when hidden too long. Images of open-source data screens appear, ordinary citizens continuing to analyze frame by frame in search of meaning. In the end, the truth about Atlas didn't vanish with the comet. It multiplied. In the silence left by secrecy, people built their own science, their own transparency. He speaks slower now, each word deliberate. Perhaps that was the real message. Not carved in metal or sent by radio waves, but in how we respond when knowledge is withheld, whether we look away or look closer. The final montage blends images of Earth, observatories, and the night sky. We began this story with a photograph, he says softly. We end it with a question, a pause. Then, in a voice almost a whisper, what if the universe is not just watching, but waiting? The music swells, strings rising, fading into a single sustained note. Text appears across the dark. The Atlas data remains classified. The signal has not been replicated. Science continues to wait. After a long beat, one last line fades in, white against black. Truth is never lost, only delayed, and then silence.